So, for some t-shirts, can somebody tell me what TL1 is? You with the hand in the back.
Transaction language 1.
Yeah.
And can anybody give me one security concern with that she'll agree with or not?
Yeah, sure.
Who said that?
It's not in my presentation, but that is a good, well, sort of,
Right. I have a wonderful O'Reilly book. Who here knows nothing about network security assessment? All right. This is Rachel Warren Bicknell now.
I got married.
Big round of applause. TL1 device security.
Thank you. So yeah, my name is Rachel Bicknell, and I am told that there are a lot of James Madison alumni here. So if they remember me, I used to be Rachel Warren, and my email address is rachel@ufp.org, and I'm going to be discussing TL1 devices and their security concerns. In this presentation, I will hold on. There we go. All right. In this presentation, I will tell you my motivation for talking about TL1 device security. I'm also going to explain what TL1 is and tools to enhance TL1 device security. I was working for a small CLEC/ISP in Memphis, where they outsourced the monitoring of all their transmission gear to the vendor. The vendor was using its own proprietary TL1 monitoring software to report alarms and outages. So when the ISP I worked for decided... Thank you. Okay, so when the Memphis ISP decided they wanted to insource the alarm reporting to save a significant amount of money, like $250,000, we looked at various options. Most of the equipment was only running TL1 and not any sort of IP addressing, thus it could not be monitored via an SNMP. To run IP on the equipment, we would have to shell out a good amount of money for their virtual IP product. No, just straight TL1. It made me kind of indignant that the vendor would make us pay extra money for something that other major vendors like Cisco would give you for free. So I thought to myself, why not learn TL1 to write a TL1 to SNMP proxy to put in an open source monitoring system. Thus I learned more about TL1 and its security features and flaws. So what is TL1? As I started looking for more information about TL1, I found everything I needed to know at www.tl1guru.com. TL1 is an ASCII-based instruction language that is used primarily to talk to telco muxes. So TL1 devices are part of the nuts and bolts that make networks run. TL1 devices include muxes, XWDM gear, DWDM, CWDM, and DSLAMs. I'm going to explain in the next few slides how TL1 devices are the hidden part of your wide area network. This picture shows how most people understand what circuits look like. You know, in this example, you have two routers that have a serial interface that connect to each other via the local bell, you know, whoever your local bell is. At ground zero, as I can show you, the circles are routers, the triangles are multiplexers. The small multiplexers in this example are T1s to DS3 multiplexers, while the larger triangles are DS3 to OC3 multiplexers. So, you know, you've got a router and it goes to the other one through the multiplexers in the network. Before TL1, every network vendor implemented the vendor's own type of ASCII-based control language. Each language was different, therefore each had to be separately memorized by operators and programmed by developers and operations system support. Bellcore, in its role to standardize as the standard setter for the RBox, decided in 1984 to specify a standard for controlling network elements. The language was called Transaction language 1. Note that because TL1 was created in 1984, it predates TCP/IP. Serial interfaces were the norm to interact with the transmission devices. TL1 also predates SNMP, which started coming together around 1987. In 1985, the first large-scale system from Bellcore was being delivered. Bellcore required the network elements to support TL1 interfaces, and vendors rapidly implemented it. Today, Sonnet and optical vendors also use the TL1 standard. Some TL1-based devices today are the Cisco ONS 1500 series, or we just call them, for lack of better wording, the Cisco ONS gear, and the Nortel Optera series. And here is a breakdown of a TL1 command. In number 1, the command code block, there is a command called set attribute equipment. In number 2, it's called the staging block, which has the name of the device, the port identifier, and the sequence number, which is like old school basic 10, 20, 30. The third part contains the parameters. In this example, one is setting the attribute of the OC3 to be in major alarm severity of loss of frame. Here's an example of retrieving all the alarms on device node B. In this case, the command outputs 3 alarms. Say it again.
Is it an overhead packet or frame that's traveling with the customer's data, or is it a separate channel?
It's a separate channel. TL1 is not a user-friendly language. In 1984, in the age of COBOL and Fortran, TL1 must have seemed as user-friendly as it came. The majority of IT people do not know about transmission devices, let alone TL1. Thus, many companies have used security through obscurity or have not used any security at all. The first thing one needs to know about how to get in and log out of the devices would be these 2 commands. One would be to ack user, which activates the user via login and password, and cancel user, which cancels the user's access to a device. So in these 2 examples, you're activating the user C15454-NYC. That is the device. Cisco 15 is your login, and OTBU +1 is the password. And the same goes for the cancel user. Here,
That's like a create, not the actual login.
no, that is the login. That's not creating the login. That is how you log in. Here are just a few default logins for various TL1 devices. I could have easily made this more than 1 slide, but I will leave that up to you guys to find. You can usually find these logins and passwords via TL1 documentation of the various products listed. If you're still running these accounts and passwords, you should probably change them as soon as possible or delete the account altogether. If you do not secure your transmission devices, one could potentially delete cross-connects that your customers use, losing tens of thousands of dollars, if not more. Delete backbone circuits that your network uses, potentially losing millions of dollars, if not more. And setting false alarms on equipment, thus panicking your NOC and wasting the company time and money trying to solve the issue. How easy is it to obtain these commands? Well, for example, Cisco has documentation that is free to the public that gives you all the commands, all the TL1 commands you could ever want or need. How can one minimize potential damage? Here are some of my following suggestions. Only allow certain network segments to access the devices, most likely through a firewall, a router access list, or a bastion host. Create logins with various levels of access as needed if your equipment does that. Some TL1 equipment does not allow you to do that, Once you are in, you are, for lack of better wording, root. Create a database that inventories your circuits and cross-connects. One could write a program to access the device, run certain commands, log the output into a text file, and then take that information and put it into a database. Anytime a cross-connect is changed, send the information to syslog or an email. And I would also recommend to delete or disable any default accounts. Here are also some TL1 commands for adding, editing, and deleting user access and command privileges. The TL1 Guru URL below has more detailed information if you want to know more. Here's some tools that you can use to modify settings remotely. Stephen Hessing has a CPAN TL1 module, and the Sarah TL1 toolkit is pretty much the best one out there. Stephen's is pretty much, he hasn't updated in quite a few years. So to explain Stephen's, Stephen Hessing wrote a Perl extension that is available via CPAN that provides a framework to develop specific commands for TL1 devices. The Sarah toolkit, which is at version 1.3.1, allows the retrieval of TL1 device information without having to know the exact details of how the TL1 command actually works. This toolkit currently works on Nortel, Cisco, and ADVA devices, but can also be used to execute TL1 commands pretty much on any TL1 device. Does anyone have any other questions? Sure. I'll get to you in a second, sir.
I guess the one slide that you had, can you go back to the one with the multiplexers?
Sure. This one?
Yeah, that one. Is it like often where like you'll have like those two, and then you'll have like a DAC system, like a digital access cross connect in between?
Say it again?
Like a digital access cross connect system?
I think it all depends on how the network is set up.
Right, but like you can have other devices in there. Are the main DACs still supported like the Alcatel 1631 SX DACs or 1100?
I believe so.
Like, are people replacing all that infrastructure with, like, you were saying, like, ONS 5454, or like, you have like 1560, 1500? Like, is a lot of that going away, or is there still a lot of...
There is a lot of old stuff still out there that people are using because, you know, kind of the if it ain't broke, don't fix it model.
Right.
So, I mean, there's still COBOL stuff out there that runs. They pretty much use the same thing with transmission gear. Do the same thing, I should say.
What about, like, I know that with those particular two devices, they have like a top stocks, TOPS. Like, that has like a lot of like syntax for TL1 that might be different than some of the Cisco stuff. At least I've read into that a few times with those two particular devices.
Well, there's definitely the standard TL1 that the RBox, the standard version, and then like Cisco, Tel Labs, Alcatel have their own like added commands to their boxes.
Right.
So that does happen.
And then I think it's the next slide. Can you it's the one on network management.
Do you remember what page?
I think it's the next one. Nope.
No. No. Which one, dude?
Yeah, that was one.
This one?
Yeah, no, back one more.
One more? Okay.
You were talking about like, this is it. But you were talking about network management systems and like how they support it, and how TL was like a difficult language to use, like user-friendly one or something like that. Not a user-friendly language. Like, are people still using the anime and Turk systems to control them, or like Turks was the provisioning system that was written by Dogform to control, like it basically spoke TL1, and it kind of like hid all that functionality underneath. And then NMA was the telemetry and like network management like architecture for it. Like, is that stuff still around too? Because like, or are they being replaced with other tools?
I don't know.
Yeah.
You.
Yes, it is.
Well, there you go.
Dogform Top 40 now is developing that software and developing it.
Sorry,
Importing it to the next
Which
generation.
one?
According to Wikipedia, it says that 18th Verizon Quest and Cincinnati Bell still use Kirk systems, obviously that right, C-like policy, yeah.
Well,
Even brand new stuff has it in it. I just had the great misfortune of spending a week in Plano at Alcatel-Lucent dealing with OLT equipment. So this is like the head-end stuff for BIOS, familiar with BIOS. It speaks TL1.
You, sir?
With TL1, is this more of an application, so it's still going to run across my IP network, or out of band, or on that out of band network, this is a serial protocol? So if it's, do I actually have to enable it, or how serious a threat is it? If it's, if it's running on my management network, do I actually have to disable it, or do I have to enable it? Or is it its own real protocol running across its own dedicated trunks?
I don't think I understood the question. Could you rephrase?
Sure. So if it's running on an out of band network, so it's not running in band as the earlier question was. So I can't send TL1 commands. I guess the question would be, do I send TL commands over an IP network, an out of band IP network, or do I send TL commands across dedicated serial connections to the devices?
A lot of the TL1 doesn't. When I was working at the Memphis ISP, we would log in. One of them had an IP address, and we would log into that one, and then we would do all the TL1 commands. There's an out-of-band channel that you can say, hey, this machine from here needs to have a cross-connect from here to here. So it literally, through the out-of-band, goes from here to here, and then then the command does the cross-connect from the two machines. Does that answer your question?
Yes.
Okay. Anybody? Sir?
I had some hopefully simple questions for you. When you started, did you say you wrote a TL1 to SNMP like converter or program?
We were in the process of doing it when I left the ISP. I do have some examples. If you want some code, I do have some examples of how to do that. We could talk about it afterwards.
Yeah, the Top 40 has one. You got to buy it. It's going to cost you a bunch of money.
This one's free.
Okay.
I've got some Perl that you can, at least an example of how you can do it.
Okay. Could you describe the process of connecting to one of these devices? I mean, I'm not in an ISP. I'm an end user site. So where am I going to find one of these devices? And I'm assuming I'm going to need a serial connection to connect to it.
Well, some of the really older devices, it would be an RS-232. So you'd literally take your laptop or computer and plug in and then, type in the commands. Some of them, like I was saying, you can telnet to one of the devices. It has enough knowledge that you can telnet to it or what have you. And then you type in the commands for all the other machines and it goes through the out of band. Does that answer your question?
A little bit. Is this device going to be, in my phone closet?
No. No, it would probably be at the Bell. It's the Bell site itself. Like we had to go to, when I was working at the Memphis ISP, we had to go to level 3 site. We had to go to, sometimes customer sites had them, depending on what kind of bandwidth they wanted out of us. But they'd be mostly located at the Bell itself, the Bell CO.
Okay. And could you just expand just a little bit more on the malicious activities? I mean, most of the ones you described they're very loud. You're going to shut something off or redirect something. Could you just talk a little bit more about the potential for maybe not so obvious damage?
Those were, I can't think of any offhand. We could talk about it. Sure, RS, what's up?
I can. But most of this stuff has monitoring capabilities, so that you can watch a data stream. Usually what you're doing is you're hooking a bit error rate counter or something like that onto it, right next to it, for instance, to watch for errors, state transitions, stuff like that. But I would say probably 2/3 of this equipment, anything that's relatively new, where relatively new means old enough to vote.
Excuse me.
Is also capable of replicating the traffic from a given port. So if you were under the mistaken impression that your T1 was maybe relatively secure and that there was no chance of somebody owning up the muxes in the CO and schlepping a copy of your traffic off some, provisioned but not in use T1 circuit somewhere else and just watching everything that goes back out and forth on the wire, trivial to do and not likely to attract a whole lot of attention.
AT&T does that for you for free.
They have a little bit more advanced methods.
Yes. So is this occurring at the left, or is this occurring at your T1 demarcation?
This would probably be happening at the left. The demarc stuff typically is not that smart. Of course, if you're in a big building and your T1s come in on an OC3, your demarc stuff is that smart. And you could have somebody, if that's your concern is, stuff that's happening inside your building, that would leave very little in the way of footprints. And, all you have to do is make a visit to the phone closet, punch down a couple extra pairs, and say, oh, yeah, this stuff on slot 17, put the transmit on port 70 and the receive on port 71, and just send them upstairs on the pen.
I worked with CPS for a while, and during my stay there, when putting in devices like LS-1544, I ran several COs that had doors that were completely unlocked, front doors, in the middle of nowhere.
I don't know what you're talking about.
And you can just walk in and start playing with an entire DAX type device.
I double don't know what you're talking about.
I can name cities where that's true.
The other thing we were discussing back here is the 15454 was the only thing we could come off the top of our heads that talks TL1 and had any concept of SSH. It does D1. All this stuff is almost without fail in the clear. Maybe on an out-of-band network, but it's in the clear. And Telnet is high
You
on.
could walk into a telco center, like a switching center, and you might have to lock it, you might have to wear an inspector suit, walk in and penetration test, and access to the
Dude, I got a co-locator badge. All I do is stick paper over the big C and it turns into a contractor badge.
Right.
Nice.
Yeah, that's what I'm saying. So that's definitely possible. And then I think probably like the worst type of attack that you can see is something like a permanent backdoring systems. I do like software insurance, so like now, and I used to do this type of thing. You can like say buzz test Williams devices if you got a hold of one, and
it's going down.
then you could create a vulnerability probably through like a TL1 interface where you could insert code that would be permanent in the system, probably even after a reboot, if the device is supposed to reboot. I mean, some devices
I will lay money on no one having buzz tests.
Yeah, and the NMA and FERC system is probably more like these systems, like assuming you get a hold of the source code, you can probably find like the typical exploitability per lines of code is like, one exploit per 100 lines of code, let's say. Like one reliable exploit per 100 lines of code. In these types of systems, I would say like it'd probably be like closer to like 70 like critical exploit vulnerabilities per 100 lines of code. So I mean, like that's it's probably pretty bad. It's not nice.
Well, I think the country there is the same for with data centers. You have the control station, you now have everything.
This is SCADA for telecom.
Yes, it is. It's SCADA for telecom.
I'm sorry to interrupt. I came in a little late. I'm sorry to interrupt. I know that people have a lot of questions want to talk about it, but I know that the sound's off, and I know people want to talk about questions, but can we have Rachel continue?
No, I'm done. This is question time.
We're done. We are already done.
Sorry, dude.
Sorry, I apologize.
Could you go to your slide with the links on it?
This one?
No, the one with the actual web link, URL.
I'm sorry.
This one? That has a web link. This one? No, that one. This one. If you want me to, I'll email it to you afterwards, or you can email me. Okay, yeah, Rachel@ufp.org. I'll be more than happy to. RACHEL@ufp.org. As in United Federation of Planets, because my husband is a Star Trek geek. For real. Go to www.ufp.org, you'll see. Anything else? No? Sir?
What's your husband's name?
Leo. Yes.
Okay, thanks.
Should I tell him who's calling?
Yeah, that's all right.
Okay.
No French.
All right. Well, if that is it, thank you very much. I appreciate the questions and the comments. Where do I go from here? Yeah, okay.
Thank you.
Thank you.
You're welcome. Oh, you're quite welcome. What do I do?